Welcome back, students. Our next topic is hydrogen bond. Now, can you think what kind of bonding is present in the water molecules? Exactly, it's hydrogen bond. Let's see what it is. Our next topic is hydrogen bonding. Hydrogen bonding, which I told you that happens in a water molecule. What actually is hydrogen bonding? Hydrogen bonding occurs when hydrogen is present with strongly electronegative elements such as fluorine, oxygen, nitrogen. They all are electronegative elements, and what happens when these, suppose I take fluorine and hydrogen, when these in a chemical bond, the shared pair electron is more towards that side, in fluorine side. So that's why electron cloud gets shifted like this, and the hydrogen here, it acquires some positive charge, the fluorine here acquires some negative charge. Similarly, if I take another HF molecule, it will have again delta plus and delta minus. Now these two molecules will attract. This is the origin of hydrogen bond. So whenever hydrogen is present with some electronegative element, there is chance of attraction of something within the molecule or with the other molecules. Such molecule is said to be polar. The molecule behave like a dipole because it carries a delta plus and delta minus. See here the cluster of HF molecules. HF. This is all hydrogen bonding between the molecules. Hydrogen bonding. This attractive force which binds the atom of one molecule which with an electronegative element like fluorine, oxygen, of another molecule of the same substance generally is called hydrogen bond. Hydrogen bond is observed in the water molecules also. Say this structure in case of water, and it is represented by a dotted line. That is a representation of hydrogen bond whenever it is formed. Cluster of water molecules may be described as H2O bracket N. The natural water on Earth, it also has hydrogen bonds because it has one 2H and one oxygen atom which is electronegative. Now what happens, they make bonds and break bonds between the electronegative element oxygen and hydrogen. You can see here that at a time bonds are getting produced and bonds are getting break also. It's like they are exchanging their dance partners, they are dancing. So this happens in case of hydrogen bonding. Now this was the case, that case was of water molecule in which I was having this kind of structure. H OH, and if I have suppose this attached with O, this is H, this is H, like that. Now let's come to the types of hydrogen bonding. We have two types of hydrogen bonding: intermolecular hydrogen bonding and intramolecular hydrogen bonding. What are these types? In this type, the first type, intermolecular, the bonding involves the attraction between hydrogen and electronegative element of two different molecules of the substance. For example, if I was writing here HF, then this is one molecule and another HF, this is another molecule. These two are getting attracted. So this is a case of intermolecular hydrogen bonding. intramolecular, in case of intramolecular hydrogen bonding, we have the attraction of hydrogen and electronegative element, but both are present in the same molecule. For example, orthonitrophenol. Now, better to recap about hydrogen bonding by a video. Hydrogen bonding, it occurs with hydrogen and the electronegative elements, as I said, that can be nitrogen, oxygen, fluorine, chlorine, anything. Now if suppose I take HF molecule, then fluorine is the electronegative element there. The electron clouds look like this, fluorine being the larger in size look like this, hydrogen is smaller in size. But fluorine, as it is more electronegative, it will shift electron cloud towards itself and it will get delta minus, and hydrogen will get delta plus as charge. And if I talk about different molecules of HF, then again due to this delta minus and delta plus, there will be strong attraction between these two and these two. So there was the formation of hydrogen bonding. Now what are the application? Application is in boiling point. You can see that decreasing the boiling point, decreasing the atomic mass or molecular mass, the boiling point is getting decreased. So this is the biggest application, that boiling point is dependent upon the hydrogen bonding factor. Also it has been observed that from H2TE, H2SE, H2S, then H2O, in case of water, the boiling point rises up to 100 degrees Celsius. Why does it happen? It happens due to factor of hydrogen bonding. Hydrogen bonding are very, very, very strong in water. So we saw the application related to boiling point of the substance. And as a result, if I talk about para derivative, then there will be increase in molar mass and hence increase in the boiling point, as we saw from the graph also, that increasing the boiling point, increase was the molecular mass, and decreasing the boiling point, decrease was the molecular mass. Now what are the applications? Hydrogen bonding is of vital importance in our clothing, because the fibers, they get rigidity and tensile strength due to hydrogen bonding. This you can see here, rigidity and tensile strength due to hydrogen bonding, the clothes which we wear, right? Then most of our food materials consist of hydrogen bonded molecules like sugar and carbohydrate. What is the formula for sugar? It's C12H22O11. Now these molecules, again, they are carbon and oxygen, which are somewhat more electronegative than hydrogen. So when present in different molecules, there will be attraction and there will be formation of hydrogen bonding. So hydrogen bonding is a great phenomena which is important in our everyday life. This is what all about the hydrogen bonding. If you have any doubts in this chapter, you can log on to www.askIITians.com. There you can go to our discussion board and you can post your question by choosing your category. You have to select your category and you can post your question here. We experts at Ask IITians will answer to your question or doubts within 24 to 48 hours. Stay tuned on askIITians.com for more lectures on physics, chemistry, mathematics and biology. Thank you.